else's device, and this is his wireless device. And from the last one, I told you I was gonna go and describe the part of the patent that just tells you how to build it. And what I did is I went over here and I just put some of the basic calculations that he put down, and then down here I just put a basic circuit of the transmitter circuit. And the waveform, it's probably not it's probably a sine wave, but it's probably special. Like, there was no, they didn't have oscilloscopes or anything, so I'm not really sure about what type of wave it was, but that's what I'm going to go with. And so in this circuit, he's just this part is a theoretical model, just showing like a long conductor. So it does the speed of light, alright, in 185,000 miles a second, whatever, and it's 925 hertz. And because of 925 hertz, it'll bring out 925 stationary waves, and then each wave will be 200 miles long. And to create something like that would be a 50 mile secondary. And so he's saying that if you had a conductor that long, which is just as long as the speed of light going, it'll set up that many stationary waves, which is, he's pretty much saying, the resonance, and each wave will be 200 miles long. So that's just a theoretical thing that he says in the patent. Now coming down here, this is basically what he says in the patent. You'll need a 50,000 volt alternator, or some type of thing that will generate 50,000 volts. Then you'll have a 0.04, I believe it was microfarad capacitor. So this is now you can see his resonant circuit that he made, and he has a spark gap, but it's a special one. It's a mechanical spark gap, they call it. And he has like a coil here, and what it does is it pulses the magnet, so it keeps the electricity from jumping at certain times. And he's got that at 5,000 times a second. And I believe this part's variable. And when you come over to the coil, he's got it. So this is the primary on the outside, and that's only like 2 winds, and that's 8,000 centimeters primary. And the he says the wire diameter is 244 centimeters, and so it gives you a total inductance of 10,000 centimeters. And the secondary, he says, it's going to be a quarter wavelength of circuit electrical disturbance. And this is the secondary with 50 turns of number 8 wire, insulated. So he says that this will end up giving you a vibrated frequency between 230,000 to 250,000. And I believe he made it so that this is variable, so you can go in between here. And when you look it down here, like, this is just like a basic wave I just made. So you have 925 stationary waves, which will be the resonant waves. And he's showed, in the theoretical one, he's showing this would be 185,000 miles, and each wave would be 200 miles, each wave. And that's theoretical. And then there's like this different ways that they show that the waves would be set up on the Earth. Some show like a pulse, and then it would be like a pulse through the whole entire Earth going across. Some show sine waves, but I mean, it's it's just all stuff because we're not sure about what exactly he had. And so it sets up these waves around the Earth, and each wave will have an energy which can be pulled down by another antenna. So that's really it. And just go look up his patent. The right patent for this would be this one right here, and that just shows it's like, I think it's the first one that he made, and that one just shows you it tells you what to make an experimental transmitter and receiver. But that's basically it. So you have his resonant circuit in the primary, and then you got the secondary, and this is grounded to the Earth. And then the transmitter is just this basic transmitter circuit right here. I mean receiving circuit right here. And that's really it for that. Now, in the other patent, his last patent that I can find of wireless electricity, we go to this one right here. And this is truly the Wardenclyffe Tower. if you look at pictures of Wardenclyffe and then you look at this, you'll see that this is like the same type idea. And so in this one, it's actually kind of different than everything that he's been saying, because he starts talking about designs of the top terminal, which in this case is like a circular thing. This is a cross section, so it's right down the middle of the whole coil, and so it's like a circular thing, and it has a bunch of little circles on it. And all this is, and it seems the most important part of it, is all these are doing is they're holding a charge in them when the energy goes up to the top terminal. And he wants, in this thing, he wants it set no discharge is going to the air, and it's kind of different than what you see in the Tesla coils that you see on the internet. And that's kind of weird, because you would think that maybe you'd have to need those discharge into the air, but that's not true. So it's the same thing. It's a resonant circuit. The G down here is for the generator, and this is a primary. And because of the cross section, it's really a coil of wire around the outside, and you can see that there's less primaries to the secondaries. And if you look close, you got the primary, which is the thicker ones, and then you got the secondary, which is the little thin ones. So the primary is wound around the secondary. You can see the secondary is grounded, just like most of the things he's been saying. And so the secondary is wound around, and it comes up to here to a coil that just keeps on winding all the way up to this part. And at this point, he calls this the hood, and it's like a slotted piece of metal which goes to a pipe, and it's just a thick pipe thick hollow pipe of conducting metal that goes up to the top terminal, which is here. So he's showing that this coil will resonate, and the pulses will end up won't be with the wire. It'll end up just flowing as if it was one conductor. And up here, this is just one conductor. It's just one thick piece of metal or whatever with a hollow middle, and so the pulses will rise up to here. And the importance here is that when it rises up to the top at the resonance, which I guess is probably just right up to here, he says that he wants it at resonance, and he doesn't want it to spark into the air, so that it will resonate up to here, and it'll come back down and flow into the ground. And it just seems a lot different than a lot of Tesla coils that you see on the internet, where you see that the electricity is just shooting off into the air. But he says that's inefficiency when you have a coil doing that. At least when you want to do large quantities of energy to be put into the air. And so if you think about it, if there's no sparks going into the air, it's probably a quiet tower. So you might think that his device would be loud, but if it's not putting anything into the air or making any type of spark, then it's not gonna have anything. But it's just the same thing. And the generator is the resonant circuit that he made. So it's like this: the capacitor and the alternator and a spark gap, to the primary. But you'd have to have this at resonance, which you'd have to probably calculate all the things. I don't know how to fully do the calculations, but I'll try to figure them out one day. And so it's just the same thing. It's grounded. What else do you say? 2 insulated supports. And he has like little specifications, like this wire that will go below the last turn. And he says it helps it from electricity sparking out of it, and so it's just holding electricity in the wire better that way. And that's basically it for this one. But that is it. And this is the patent number, and this is when it was filed. So this is probably right off the Wardenclyffe Tower. So he just wanted to patent that and show you that that's when it was what he did. And so that's it. And I think that's all I'm going to do for this. But it's pretty cool, because you see the Tesla coils on the internet stuff, they're shooting off sparks, but he doesn't want that to happen, because he says that's the inefficiency, and so maybe that's the secret. But that's his coil. Alright guys,